So trigonometric form for complex numbers. So the definition is with x equals r times cosine theta and y equals r times sine theta, a complex number z equals x plus yi can be written as z equals r times parentheses cosine theta plus I sine theta. All right, so let's go do some problems, and I have to prep this a little bit. All right, relatively simple here. Write each complex number in standard form. So cosine 30 degrees is 0.866, but notice the 2 in the front, so it's going to come out to a rounded 1.73. Sine 30 degrees is 0.5, but with the 2 in the front, we're going to have 1, which means we're simply going to have this I here, and there it is, 1.73 plus I. Notice that the second problem looks almost identical to this one here, except it's 4 times what we have here, so instead of 2 times. So we're going to get this one here, 3.46 plus 2i. So write these complex numbers in trigonometric form. And this here is then from the book. So here we have the complex number, so x on the x-axis and then y on the y-axis, so x plus yi. And then to get them into polar coordinates, well, the r is the distance here, and we can see the Pythagorean here. So x squared plus y squared, that's the r, and take the square root, of course. And then for the angle theta, we can see, well, it's going to be y divided by x. Take the inverse tangent of that. That's going to be the angle theta. And we can see that here in the summary or definition. There it is, square root of x squared plus y squared equals r. And then over here, tangent theta equals y over x, or the inverse tangent would be the theta. All right. So this one is going to come out next to, well, here's the r. So 3 minus 4i is the first problem. And, oh, it's a little bit off screen there, that's better. So 3 minus 4i is the first problem. So r equals the square root of 3 squared plus negative 4 squared, which is going to be 9 plus 16, which is 25. Take the square root of 5. So r is 25. And then for the theta, it's going to be, take the inverse tangent of negative 4 over 3. So the y over x comes apparently out to 307 degrees, and I can show you that on the calculator. So inverse tangent of negative 4 over 3. There we go. And by the way, it's going to come out to negative 53, I believe. Yes, it does, negative 53. And we're in the fourth quadrant, so negative 53 would be correct, but I guess we want to have it as 307 degrees rounded. So therefore, that can be now rewritten. So x and y are in quadrant 4, yeah. That can be now rewritten as such. So 3 minus 4i equals that 5 in the front, the r that we have, and then times parentheses cosine 370 degrees plus I sine 370 degrees. Now the 370 degrees here, cosine of it, is the same as actually the cosine of 53 degrees, same in the fourth quadrant as the first quadrant. And then for the sine, well, the 370 degrees here would be then, as it is in the second quadrant, if I substitute the first quadrant here, that would actually introduce another negative with that as I come from the fourth to the first quadrant for the sine. Okay, so the final answer is 5 times parentheses cosine 53 degrees minus I sine 53 degrees. All right, this one here, 3 plus 4i, by the way, this part here looks really similar to the earlier one with the 3 and the 4. So again, we're going to come up with r equals 5. There it is, 3 squared plus 4 squared. Take the square root, that's 5. And then the tangent, the inverse tangent, that is, This time around it's 53 degrees, and this one here, the 3 plus 4i, is going to be in the first quadrant, as we can see from this diagram here, so they're both positive. And then the last one, as it said, it was a 3 minus 4i, that actually puts us in the fourth quadrant for the last problem. All right, so 53 degrees, I don't think I have to type that into the calculator anymore because I already did. So 53 degrees in the first quadrant. There it is. And then this time around it's really straightforward. 3 plus 4i equals 5 times cosine 53 degrees plus I sine 53 degrees in parentheses. And that is, to my knowledge, the very last thing I'm doing in this entire trigonometry class.